Let's clear out some of the usability things here first. I think I'm gonna close that. Which is basically gate duplicating is holding the shift. So gate duplicating is holding the shift. Yeah, okay, that's cool. And removing a gate is just the middle click. Yeah, okay, nice. If I'm using just the pad, like the mouse pad, it might be a bit complicated to do the middle click, I think, in my laptop. But that's I'm using mouse now, so that's okay. So that's good enough. Gate deleting, yeah, column dragging control. So column dragging control. Nice, perfect. Column duplicating, it's control shift. Okay, powerful. And row dragging. You can drag entire rows of gates by holding the control key and then dragging the initial state indicator. Okay. That'll be easier to see like this. Okay. Curious to see how this works with controlled operations. Okay. Yeah. And even if I do like that. Okay, cool. Yeah, it's fairly intuitive, I think. I think it's fairly intuitive. That kind of bothers me a little bit that the tutorial is there all the time, but change initial state, gate resizing. Okay. Yeah. That's cool. Okay, perfect. So what I'm trying to do here is I'm going to be spending, I think, the next videos. I'm going to park everything else that I've been sort of exploring for now, and I'm going to be trying to coin some terms around uncertainty, some things that kind of make sense to me right now, maybe just absolutely nonsense for everyone else, maybe it doesn't really take me anywhere, but I wanted to explore a bit what you can do with superpositions other than just like uh, arithmetic. I mean, at the end of the day, kind of everything can be boiled down into arithmetic, really. But just want to play with it, see what do we encounter, what we can do, what we cannot do, and kind of all, playing with that without any specific aim. I think one of the problems that I'm kind of struggling with right now, or that I see a lot of people struggling, is that there's a constant strive to justify the industry applications of quantum computing, and I think that might be blindsiding us, uh, you know, in some angles, because we're trying to kind of make a step that we are probably too early to make yet, and then that's maybe the reason I feel the way I feel about all the machine learning stuff that I've been seeing, is that it's not there yet. I think there's some, of course, advantages and some things that we can see in simulating and chemistry and stuff like that, but I really haven't explored that yet. I'll just put it aside for now and try to understand a bit more the first principles of working with superpositions. And I think that's because the thing with the thing so Craig's post about the x-axis controls and y-axis controls kind of opened my mind up a little bit, in the sense that there seems to be some stuff to explore there, and I think that can be interesting. So let me just start by coining those terms first, and because I talked in some videos, like almost the very beginning, about positive uncertainty, negative uncertainty. Some people who are watching the videos are asking me to do more in that direction, but this is not really any kind of official, or any, I haven't seen this anywhere coined this way. So uh, basically my thought process is the following. So, and I'm always thinking from the z-axis perspective, as in this being the computational basis. And maybe the block spheres will help me explain that a little bit, but of what I kind of have in my mind. So for me, when I talk about like positive and negative uncertainty, this is actually, I should probably call it real uncertainty. This is what you get when you do a Hadamard, or when you do a Hadamard with, like, using a knot, like a one as a seed. And I'm really going to be using seed because I like the concept of I like the concept of having sort of a seed to create to get into superposition, because that takes you into a different type of uncertainty. But at the end of the day, if you just restrict yourself to seeds which are made of zeros and ones, so seeds that are living in the z-axis, what you're going to get with this superposition is rather so you're and if we stick just with one qubit, you're just going to either stay at the sort of the minus or plus states, right? So this is the 0 plus 1 divided by the square root of 2, and 0 minus 1. And this would be the negative uncertainty, and this would be positive uncertainty. But it's kind of real in the sense that there's no complex component. It's all happening with the y-axis being 0, right? That's why I call it real uncertainty. Following the same analogy, the same concept, you can define complex uncertainty. In this case, is the type of uncertainty that you see that it's only living in the y-axis, and you would do that by, for example, getting into the plus state, and then applying a is it an S? Yeah, and that's a quarter turn. So an S, and that would be, in this case, just look at the first qubit. So in this case, that's this, right? So you still got a 50% chance of observing 0 and 1. If I would do it this way, you kind of have this. So you've got 50%. You've got the 25% chance of seeing any of those values. But basically, what's interesting here is that I kind of see that the amplitudes. That's interesting, because if you can see, the phases are 0, 90, 90, and 180. That's really interesting. So, but you see, basically, these are all the complex uncertainty would be the uncertainty that lives only within the y-axis, or basically it's uncertainty that you can use basically real seeds. So you can use the values in the x-axis as a seed, or you can use just a combination of we start from 0 or 1. You can use a combination of a Hadamard and an S, right? So that would be the same. I just kind of it makes it more compact. I like this. And so, and if you are now, what happens if I do that exactly? So if you now do that, you basically end up at the other side of the so that of the uncertainty. That would be basically, I think, the equivalent of minus I, exactly, and that would be complex uncertainty. That's how I would coin the term, and it's really anything in between. I mean, it can also be, I don't know, yeah, of course, that's not uncertainty anymore, because you're back at 1 here. But if you would say like a quarter, right? That'll be another example. That's a cool one. That's interesting. So basically, I'm interested in seeing what's kind of, what is the shape of those uncertainties, and what can we do with that? What can we engineer here that is kind of unique and interesting? And I don't know. I don't even know where to start yet, but I think I just wanted to drop this video coining the terms, and then laying kind of the foundation for my next videos to explore these. Because of course you can have a mixture of uncertainties, right? And So if I would now kind of rotate, if I would now rotate what S, right? So now you've got a mixed up of real and complex uncertainty. Interesting, because if I do that, you can just basically because exactly you're not. Yeah. That's how I would call it. Interesting. It's funny to see that, like, by adding those S gates, so you've got all the. It kind of aligns all the phases, all the relative phases. Interesting. Without touching the amplitudes. So I don't know. I think probably the next is I maybe should kind of set some internal guidelines in terms of what do I want to play with and how do I want to play with this. But basically that's it. So I talked about this real uncertainty, complex uncertainty, and then the real uncertainty can be, of course, positive and negative, and the complex uncertainty can also be positive and negative, as we just have seen, right? So that would be, I would call that negative complex uncertainty, but we can also just do positive, and that would be the I. And the opposite being, in this case, if you negate, so you can, for example, what I can already see here is complex uncertainty can be negated. So you can negate it with you negate it with the x axis, okay, with the x gate. Interesting. Whereas if you go to positive or negative uncertainty, in order to negate that, you need to apply the y gate, I think, yeah? No. Not entirely. Interesting. Because what if it's positive uncertainty? Also not. Interesting. But why? Huh. You see, that's pretty cool. So you've got, okay, so if you've got positive uncertainty, then you apply, yeah, of course, that makes sense. So about shift. So that kind of keeps. I really think that if I find the time, I'm really gonna try to work on extending the quirk to change the colors here, so it's easier just with a glimpse of an eye to see whether you're, because color coding the inside of the bolts, or maybe the color of the amplitudes here will kind of help me kind of visually see if it's the same or not. Because here I have to kind of look here, and then say, okay, that's the same, but that's flipped, and that's the same, right? Yeah, but basically, of course, that's, as I said, that is negated in the sense that this is the same as, like, this is the shape of negative uncertainties. If I do that, and if I go minus, yeah. Okay. Yeah. What else can? What I'm pretty curious about is kind of to try to study and take a look at how, for example, let's say we're here, and then how do the different raising gates will affect the the uncertainty, right? Because if we're only rotating one, that's interesting. You see, it only rotates there where there's a one component, and here it will rotate there where there's one component in the first, exactly. So it rotates. Okay, interesting. Whereas if I do this, then rotates the phase on all those. Although and this one rotates way faster, right? Because it has like twice the component. Interesting. Whereas if we play with a Y gate, of course it doesn't do anything. If we play with the X gate, it actually plays with the amplitudes, which is beautiful. And we see that it kind of tends to go to the extremes, 0, 0, 1, 1. That's also interesting. And what if we rotate them sort of the other way around? Oh, beautiful. Yeah, kind of makes sense. Kind of makes sense. Now the 0, 1 and 1, 0 are the ones that get the maximum, the peaks of amplitudes. It's interesting. Yeah. I think what's interesting, one of the things that that we'll explore in the next video is probably kind of the creation and destruction of those uncertainties, so sort of the interference effects, right? Because kind of the Hadamard feels like a special gate in that sense, in the sense that it's a gate that helps us go from it helps us create uncertainty, the real uncertainty, and at the same time it has the opposite effect by basically, it's the same gate, it's kind of then interfering and going back to like a non so to kind of like our certain basis. What if you do something like that? What's the effect? Okay, it actually negates the superposition. Interesting, but not entirely. You see, the interesting effect is no. Okay, it kind of so this goes from 90 to 0. This goes from 0 to 90. This goes from 90 to 0, and this goes from 180 to minus 90. Interesting. So this is one thing that I want to play with. Another thing that I play with is the x-axis controls. I want to play with post selections as well. Because if I apply a y-axis control now, a minus I, so here kind of really flips the phases. Okay. Yeah, I got to think a little bit about it for this not to be too unstructured either. It's like, what do I want to explore? I like to kind of have it to be more like, okay, can I do that? Can I not do that? How I would do that? How I would do that? But basically, this is what I have in my mind. So real uncertainty, complex uncertainty, both positive and negative. How do we create those? How can we interfere? And how can we and what can this be useful for, other than operating in a superposition, as in like applying operations to and why is it useful? So for me, one of the biggest questions here is like, why? So what is the advantage of having two types of uncertainties? That would be one question, right? Is it just a dimensionality thing? Is it just that we can even do more than that and then have so what if we have this what is this even? So now we have sort of a mixture. Interesting. I'm a bit over. I feel a bit overwhelmed. I don't know if that was a good idea. Yeah, but I kind of think. I kind of feel like that there's some stuff in there to explore. I feel like a bit of a, like there is something super powerful in front of me, which, but I don't know how to use it, and then kind of like it's dangerous because don't want to run into, kind of like rabbit holes of asking weird questions and try to spend a lot of time understanding things without really any aim. That's not the way I want to spend the time, but nevertheless I feel like I should actually kind of just jump in and explore. um yeah, but basically that's it. So we've got different types of superposition. How can we make them interact with each other? That will be another question. Maybe we should just write down those questions. So how do we create those with seeds, and what are the characteristics of those types of uncertainties, and then how can we kind of interact them? Or I don't know. I'm a bit confused. I'm a bit kind of half lost, half clear, but yeah, let's see what happens.